Hello, future Hunter. This is Hunter of the past. Today is June 11th of 2024, and you are trying to remember how to calculate the rate of how fast something is filling. With this specific problem, we have an inverted circular cone like this, which leads down to a point, and it has a base radius, so here, of 2 meters, and a height of 4 meters. And is being pumped into the tank at a rate of 2 meters cubed per minute. So we'll say going in at 2 meters cubed per minute. And the water level is rising. So we need to find the rate at which the water level is rising when we're at 3 meters deep. So 3 meters is probably going to be around here. Okay, so if you're paying attention, Hunter, you've got a triangle, right? You've got a triangle right there. This is 2, this is 4, and then somewhere in here we have R and H. So the same that R is in ratio to 2 is going to be equal to the ratio of H to 4, because as it grows, it actually equals the same thing, right? Okay, and then we also need to find the volume, and a volume of a cone is 1/3 times pi times r cubed times h. And from there, let's see, where do we need to go? Well, we know that h will be 3, right? And we know that, hold on, I'm thinking here. I'm thinking. Okay. Okay, well, first off, let's solve for 2, right? I mean, solve for r. So r equals, and then you take the 2, times it over here. That divides this, so it's h over 2, right? That makes sense. And this is when h equals 3. So this shouldn't be too hard, but I feel like there's something I need to do before that. So we need to find the derivative, because in order to find the rate of something, then you find the derivative of that something. So we have the derivative of the water being pumped in. So we need to know how fast it's rising. I'm looking at my notes right now, that's why I'm not doing everything all at once, because I'm actually thinking. Okay. Okay, so we have the volume, right? Volume equals 1/3 pi times r. Wait, is that supposed to be cubed or squared? I think it's supposed to be squared, isn't it? Yeah, that's supposed to be a square. Squared. And r, we just found out, is h over 2 times h. So we can then simplify this as h squared over 4. And then we can simplify this more. So this becomes pi times h cubed over 12. That is what v equals. And I'm pretty sure at this point we can pretty much just plug in. No, maybe not. Looks like we need to take the derivative at this point. So dv over dt, that's the derivative of the v, would equal d over dt of, let's separate this and go pi over 12 times h cubed. And then in order to find the derivative, I believe in this case, okay, well, let's look at the chain, right? So if we were to take the chain, then we'd have derivative pi over 12 times h cubed plus pi over 12 times the derivative of h cubed. So we know that the derivative of anything without like x or a variable is going to be 0. So this side is 0 plus pi over 12 times, oh, that's a bad 3. Why is my z not working? Okay, that was weird. Times 3h squared. Okay, but you also have to take the derivative of h into factor, right? Let me be sure here. Yeah. So when you take the derivative of h to the third, it's going to be like y equals u to the third and u equals h, right? Then you find the derivative of both, which is, so y prime equals 3u squared and u prime equals h prime, and so then you times those together. So down here, what that looks like is we just times it by the derivative of h. Okay? And so from here, I think at this point now, maybe, yeah, we can now plug in 3 for h. So right off the bat, this 3 and this 12, those can cancel out. So that's going to be pi over 4 times h, which is 3 squared, times the derivative of h of dt. And we know, what do we know? Oh, that's what we know. So the derivative of the volume actually is given, right, with the 2 meters cubed. Why is my okay, that's really weird. My my undo button is not working. I'm gonna have to look into that. What am I saying? Oh, this is the derivative of the volume already, because we know that is filling at that rate. So we set this equal to the derivative, which is just 2, and then we can solve for the derivative of the height as it's rising. Okay, so let's simplify this before we move things around. That's going to be 9 pi over 4 times the derivative of h, dh of dt, or dh over dt, I mean. And then we got to divide, or times, by the reciprocal to make that equal to 1, and then put it over on this side as well. So that's going to be 8 pi over 9 equals the derivative of h. I can make that pi look a little bit better, but that is our answer right there. Okay, my Command Z is still not working, but that's our answer. Great. Brilliant, Hunter. I'm hoping that you actually look back at this moment. Yeah, interesting. Well, I guess it's meters per minute, yeah. Yeah, okay. Thank you. Not thank you, don't say thank you. According to speech class, they say don't say thank you, but I need to end, so